Hello and welcome back. In section 3.1, we start looking at logic statements and connectives. So we'll start with our OR. Now, in everyday language, we tend to use the exclusive OR. So, for example, do you want to walk or drive? So you're going to a destination, option A or option B. You can't both walk and drive typically. In math, we use the inclusive OR. Similar to what we did in the set theory work we did in chapter 2. So, for example, let's go to dinner or a movie once this pandemic is over. This is an inclusive OR. I'm going to have dinner only, movie only, or maybe both. So really 3 possible outcomes would be covered here since we're using the inclusive OR in any math statements, unless we're explicitly told to use the exclusive. We'll assume we're using inclusive in this course. So not too different from our work in set theory so far. The next logical connector we'll look at is the if-then. So this is used if we're connecting 2 ideas. Just a simple one. If a number is even, then it is a multiple of 2. So just a short, simple if-then statement. The concept of a number being even, the concept of a number being a multiple of 2. We also want to look at the idea of statements. So statements are ideas that are either true or false. Some examples, 5 plus 2 is equal to 6. This is a statement. Happens to be a false statement, but false statements are still statements. We are working in section 3.1. This one happens to be a true statement. But both of these are still statements, whether they happen to be true statements or false statements. And now that we have the idea of the statement, I want to look at the idea of the negation of a statement. So the negation of a statement will have opposite truth value. Now, the negations are typically also used with quantifiers. Well, let's look at a couple short examples before we hit the quantifiers. So, for example, a statement Ben is black. This one happens to be a true statement for what I'm doing right now. So then the negation, the pen is not black. So this one happened to be true. This one is false. Now, negating statements with quantifiers is a little bit more challenging, but if you think through the reasoning, you'll do just fine. So looking again at quantifiers. So if your statement is all are and then some property, in the negation, then you're claiming you have at least one that is not. So our negation would be some are not. We have at least one that does not have the property stated. A common mistake with the all are negation, a lot of people just want to throw a not in front of it and say, okay, well then that means none are. But again, a negation has to have the opposite truth value. So watch out for things like, if I say all people are left-handed, that's a false statement. The negation can't be no people are left-handed because that is also a false statement. They have to have opposite truth values. Similar idea to none are. Sometimes it's no depending on the sentence structure. No or none are, and then our descriptor. So we're claiming nobody has this property. The negation would be at least one has that property, so that would be a some are. Some have that property. Some are is claiming that we have at least one with this property, so the negation would be that none have that property. If I'm claiming some are not, and you want to have a negation of that, This is basically saying I have at least one without this property. To negate that, then you would have to claim all have that property. So some examples. If my statement is all cups are made of glass, if that's my statement, then my negation, all are, the negation will be some are not. So some cups are not made of glass. If my statement is that some pens are blue, see if you can come up with the negation. Go ahead and pause it, see if you can write it up, and unpause it when you're done. Okay, welcome back. So my claim that some pens are blue, so I'm claiming I have at least one blue pen. Your negation would say that, okay, you don't have that. You don't have at least one blue pen, so there are no blue pens. So no pens are blue would be your negation. And again, watch out for that common error. So your negation is not of the form some pens are not blue. The reason being, some pens are blue is a true statement. Some pens are not blue is also a true statement. A negation can't have the same truth value as the original statement. So watch out for that common error. I have you all try one more, so I'll make a statement. My statement is some people do not drive trucks. See if you can come up with a negation. Okay, welcome back. So my claim is that I have at least one person that does not drive a truck. If you're claiming that I'm wrong on that, then you're claiming that it's not possible for me to come up with at least one person that doesn't drive a truck. So that's saying all people drive trucks. And again, you might be saying, well, that's not true. Maybe you yourself don't drive a truck. Remember, statements can be true or false. So our original statement happened to be true, so our negation had to be false. So next we look at the idea of the compound statement and the simple statement. Simple statements, basically one idea that is either true or false. Compound statement connects two or more simple statements. And it would usually use things with either and, or, and we saw the if something, then something else. When we're performing operations on them, we can represent simple statements with lowercase letters. Usually P, Q, and R. Let's see. One other that I haven't looked at yet, the idea of not. That is a negation with the symbol of a tilde. So if statement P is that Florida is a state, then the negation, which would be not P, in symbols, we'd have the tilde followed by the P, which would be Florida is not a state. Some other symbols. We have the conjunction and. And our symbol for that looks kind of like the and in our set theory, only it is sort of pointed instead of rounded. You may also see, in addition to and, the sentence could also use the word but. However, nevertheless, those are also imply that we're working with a conjunction. For example, the door is red and the desk is green. So if I use P to represent the statement, the door is red, Q to represent the statement, the desk is green, then in symbols, my sentence would be door is red, so that is statement P, and the desk is green, Q, P and Q. Washington, D.C. is a city, but D.C. is not a country. So here, my statement P would be Washington, D.C. is a city. Statement Q, Washington, D.C. is a country. So our combined statement here, Washington, D.C. is a city. But remember, that was one of our possible uses of the and symbol. Washington, D.C. is not a country. So if Q says it is, not Q says it is not. So next we look at the or. So for this one, the statement will be, our symbol, by the way, kind of looks like the union symbol again, except pointy. So P will be, the book is green. Q will be, the book is 2 pounds. So see if you can translate into a sentence what I've written in symbols here. And go ahead and pause if you need to. So this one is just P or Q, so my sentence would be, the book is green, or the book weighs 2 pounds. Have you also try P or not Q, see if you can write the sentence for that. Pause it if you need to. Okay, welcome back. So the first part is the same, the book is green. Or, this time the negation though, the book does not weigh 2 pounds. So you should get a little bit of practice working back and forth between the symbols and the sentences. Commas. That in this case, commas will tell us which to group together. So this is when more than one connective is used. Commas tell us which to group together. And typically we would use parentheses to do so, just like in your algebra days. So for example, car can be sold with sunroof. And MP3 player, let's say it's an older car. Or a heads-up display. So this is saying these two are grouped together. So this would be P and Q grouped together, or R. And the if-then statements the symbol for that is an arrow. So this would be read if P, then Q. So for example, if statement P is the phone is ringing, Q, the dog is barking. So in symbols, if we have this written down of P with an arrow, then a Q, the order does matter. So if the phone is ringing, then Q, then the dog is barking. I'll translate the other way. I'll give you the sentence. See if you can give me the symbols. Again, pause it if you need to. Welcome back. So if the phone is not ringing, so this would be not P, the negation of P, not ringing. Then the dog is barking, so if we kept it as is barking, that would be a Q. Similar seeming one, but with different truth values. It is false that, and then our compound statement. It is false that if the phone is ringing, then the dog is barking. So it is false that says you're going to negate a compound part, and then we say, so it is false that, that's up to here, so the negation and the parentheses, and then after that, whatever it is we're negating. So if the phone is ringing, then the dog is barking. So again, looks similar, different truth values though. So I'm going to have you all do one more translating, and then we'll look at the biconditional. So P is going to be the pen is blue. Q is going to claim the paper is white. And statement R, the sign is red. Okay, so go ahead and pause that, see if you can write the sentence out. Okay, welcome back. So we'll start with just left to right. So we have an if then, so if P, so if the pen is blue, then not Q, the paper is not white. And then a comma because we grouped all of that together. And then after the comma, R, the sign is red. And our connector here is an or. So or, the sign is red. Let me have you translate another, again, similar looking one. We've just moved the parentheses. So go ahead and pause that, see if you can write the sentence for that guy. Okay, so we have the same P, Q, and R. So this time, again, we have an if then. So if the pen is blue, comma, then not Q or R, the paper is not white, or the sign is red. And again, just moving those parentheses, not only will the signs sound and the sentences sound a little bit different, it will change meanings as well and truth values. Later on we'll learn about truth tables as well. All right, so next up on this, let me pause